Okay, so where we left off, we were looking at the different model, or the history of the atom, I guess. And we got to John Dalton in 1808, who proposed his modern atomic theory. And from it came the billiard ball model. But in his modern atomic theory, he proposed that pure substances were made up of small identical particles. So if you took a substance, I think I said like gold, and you broke it down into its smallest particles that we called atoms, all those particles would be the same. But if you had two different pure substances, and those pure substances are what we called elements, if you had two different ones and you broke them both down into their tiniest possible particles, those tiny possible particles, called atoms, would be different in the gold than they would be in the sodium, than they would be in the aluminum, than they would be in the uranium. Okay, and they'd have different properties. Then his third thing he suggests was that combined substances, which we call compounds, are made up of combinations of different atoms in a set ratio of simplest whole numbers. That's where I was as the video went off. Okay, so he's right about these things, but he wasn't right about his model. The billiard ball model, if you remember, I think it saw it as like, inseparable, hard, firm. We know none of that is true now. But before we get to the other models, we need to talk about a couple of other spots in history that the atom came up. One was by a guy that I think you've heard of. His name was Avogadro. And I think maybe it's Avogad. Yeah, Avogadro. And it's Avogadro's number that I'm thinking you would have heard of. You celebrate it once a year. Avogadro is the guy that figured out that atoms combined in sets, that there was a set number of atoms that are molecules that always seem to be together. And that number was 6.02 times 10 to the 23rd. So there were this many molecules or atoms in a mole. Okay, so Avogadro's number. So again, going back to that idea that you can break things down into their tiniest parts again. Okay, Avogadro worked a lot on trying to determine both the mass and the size of an atom. The next guy up, and I know you've heard of him too, is J.J. Thomson. And J.J. Thomson, I don't think he has a P in his name. He's around 1897. And he's the one that suggested depending on what chemistry teacher you had, the plum pudding model, or some people call it the raisin bun model. I kind of like the chocolate chip muffin model better because I'm not a big fan of raisins. So what Thomson suggested for what this atom looked like, so we're now trying to figure out from Dalton's time, really, what does this atom look like? And so Thomson suggested his model was that it was a uniform distribution of positive charge with negative charges embedded in it, right? So if this is my atom, there's positive charge uniformly distributed throughout the whole thing, and it would be like the batter in the raisin bun, in the plum pudding, or in the chocolate chip muffin. And the negatives are embedded in them. They would be like the raisins or the chocolate chips. So everything else would be around it would be positive, right? So it's like the batter or the pudding part, and then the negatives are embedded in it. Okay? His model got disproven when later the electron was isolated. The electron was isolated in 1909, and when that happened, then his model was disproven. The good news for J.J. Thomson is the person who isolated the electron was J.J. Thomson. So at least he got to disprove his own model as opposed to someone else doing it for him. So if there's a silver lining, that's probably it. All right, and that's 1909. So after 1909, then they began saying, okay, wait, if we can isolate the electron, then obviously the atom isn't indivisible, and we need to come up with a better model. And so the next one on the scene, you know him well, I think, is Ernest Rutherford. Ernest Rutherford. And Ernest Rutherford proposes his model in 1911, so not long after Thomson isolated the electron. His model is known as, I think you would probably know it as the solar system model. It's also referred to as the nuclear model because he's the first one who suggests there's a nucleus. Okay, so the solar system model or the nuclear model. And he does a really famous experiment that leads him to his model. And that really famous experiment is what we're going to start next day with, well, after we go over the homework. Okay, so this early history is really just getting us to Rutherford, and then, of course, after Rutherford is Bohr. So I want to do Rutherford's famous experiment with you in person. So we're going to stop there for today.